Hey guys, today we're going to talk about the important concept of gases. One of the most important yet general terms when dealing with gases is pressure. Pressure is caused by atoms or molecules colliding with its container. There are 7 units for pressure: Pascal, which is 10 to the 5th neutrons per square meter, kilopascal, atmosphere, millimeters of mercury, torr, bar, and pounds per square inch. Atmosphere will be the one you use most commonly. All of these units coincide with each other. 1 atmosphere is equal to 101,300 Pascal, which is equal to 101.3 kilopascals. That is also equal to 760 millimeters of mercury, which is also equal to 760 torr. So 1 bar is also equal to 10 to the 5th pascals. In order to find the condition or state of a gas, you have to know 4 very important variables: temperature as T, pressure as P, volume as V, and the amount of gas or number of moles, N. Each of these variables have a relationship through equations called the gas laws. The first and most important gas law is called Boyle's law. It states that at a constant temperature, the pressure and volume are inversely proportional. So as the picture shows, as volume goes up, pressure goes down, and vice versa. The next 3 gas laws are closely related to each other in a sense of the variables because they are directly related to each other. So in Charles's law, when the pressure is held constant, the temperature and volume will be directly related. So as one goes up, the other will too, and as one goes down, so will the other one. Lusak's law has the same concept as Charles's law, except instead of pressure being held constant, it's volume. So in Lusak's law, when the volume is held constant, the pressure and temperature are directly related. So as pressure goes up, so will the temperature. In Avogadro's law, the volume of a gas at a constant temperature and pressure is directly proportional to the number of moles of gas. So as the volume goes up, the number of moles will go up, or as the volume goes down, the number of moles will go down. When dealing with gases, the ideal gas equation is one of the most important equations that you can use. This equation is PV equals nRT. P equals pressure, V for volume, N for number of moles, T for temperature, and that's in Kelvin, and R for the gas constant. When looking at the gas constant, you're given 3 different numbers. When you are doing the actual equation, you'll know which one to choose by looking at the other variables. For instance, if the other variables include liters and atmosphere, you'll know to use 0.08206. As stated earlier, your temperature must always be in the unit of Kelvin. So, to do this, you have to add 273 to the degree that you were given in Celsius. Let's look at an example. Water at its freezing point is 0 degrees Celsius. So if we want to know what that is in Kelvin, we have to add 273 to it. That makes it 273 Kelvin. Water, at its boiling point, is 100 degrees Celsius, so if we add 273 to that, it becomes 373 Kelvin. Let's try out an example problem. At 0.536 atmosphere and 93 degrees Celsius, how many moles of H2 are contained in 682 milliliters of gas? So we were given all of our information in the problem, but there are some things we need to fix, such as temperature. It was given to us in Celsius, and we need to change it to Kelvin. So we add 273 to 93 degrees Celsius, and that becomes 366 Kelvin. This makes 366 Kelvin our T variable, or temperature, for our equation. We were also given 682 milliliters. We had to change that to liters, and when we did, it was 6.82 liters. That will be our V variable for our volume. For the R variable, or the gas constant, we will be using 0.08206 because we are also using liters and atmosphere, so it has to match up with each other. Now we didn't go over the P variable for pressure because that was one that was given to us. So, since we have everything else, we really just need to plug in everything. Now we need to start simplifying the equation. Multiply 0.536 with 6.38. That gives you 3.41. You also need to multiply 0.08206 by 366. That gives you 30.03. Now remember, we're still looking for the number of moles, so take 3.41 and divide it by 30.03. This will give you your number of moles as 0.114 moles of H2. So now that you know which 4 variables are included in gases and which 4 laws affect those variables, you can go off and try your own problems. Thanks for listening.